Well, has the total amount of energy and matter always been the same? Well, according to orthodox science, there's one major exception to this rule, which is the moment of the Big Bang itself, when all the matter and energy of the universe is suddenly supposed to have appeared from nowhere. Well, some scientists try to explain this by saying, well, actually, it came from the quantum vacuum field, sometimes called the zero-point field. But the quantum vacuum field of the universe is not, as its name vacuum might imply, empty, but rather full of potential particles, of potential sources of energy. And according to standard quantum physics, this quantum vacuum field is generating virtual particles all the time. I'm sitting down now, and I'm not going through this chair because the chair and my bottom repel each other. And the reason they repel each other is there's a repulsive force, which is ultimately electromagnetic. And the reason that repulsive force is happening is because virtual particles are appearing in the quantum vacuum field and causing this repulsion to happen, which is why I'm not sinking through the seat of my chair. If you could see it, there'd be a sort of great glow under my bottom. And if I lift my bottom off the seat, and now the glow's stopped on the seat of the chair, it's now on the arms where I'm resting my hands, I sit down again, and all those virtual particles suddenly start appearing again under my bottom. Well, the quantum vacuum field is part of modern physics, and some people suggest that the universe began from a fluctuation in the quantum vacuum field. Well, that's just putting the source of energy further back. Doesn't explain where it comes from in the first place, of course. But when we come to the actual workings of the universe, is it actually true, as opposed to a satisfying philosophical idea or a rule of scientific accountancy, is it actually true that the total amount of matter and energy is always the same? Well, physicists aren't as cramped in their style as the rest of us, and if they need to invent or recognize more matter, they can do so at the stroke of a pen. In the 1930s, a Swiss astronomer called Fritz Zwicky was studying the way that galaxies are clumped together in groups in the universe, and he found that the galaxies were attracting each other much more than they ought to, according to the amount of matter they had in them. They had far too much gravitational pull, apparently, than they should have done. Well, no one paid much attention to his observations until in the late 20th century, people found that stars within galaxies were moving too fast around the galactic center to be explained in terms of normal amounts of matter in galaxies, including gas clouds, brown dwarfs, and other stars that can't be seen. They made a generous allowance for all known forms of matter. And the equations of gravitation simply didn't work for explaining the structure of galaxies or the interactions between them. So how did they cope with this? One way of dealing with it would have been to think that there's more going on in the organization of galaxies and galactic clusters than simply gravitational pull. Or there was the possibility that the laws of gravitation were wrong and needed modifying. And both of these possibilities were explored by a tiny minority of scientists. But the majority decided to stick with regular gravitation and account for the behavior of galaxies by adding in extra matter, called dark matter because you can't see it or observe it in any normal way, to account for this gravitation. So how much dark matter should they add in? Well, that's simple. You just find out how much matter you'd need to explain the behavior of a galaxy or the interaction of galaxies, and you titrate in the exact amount of matter needed to make the equations balance and give the right answer. And if you then discover that galaxies are behaving a little oddly, there's a bulge in one part of a galaxy that you can't explain, you add a bit more dark matter in around the bulge to explain the bulge. This explains everything in the most satisfying way, except that nobody knows what dark matter is, and there's no independent evidence that it actually exists at all. So basically, physicists have invented a new form of matter, about 5 times more than known forms of matter. And where does this leave the principle of conservation of matter? If physicists can actually invent it, fit their theories in vast quantities, inconceivably vast quantities, and then, if they change their theories, de-invent it, is matter really conserved? Does dark matter interact with regular matter? Can they be converted to each other? No one knows, because no one has a clue what dark matter is, and all attempts to detect it experimentally have so far failed. So it's quite possible it doesn't exist at all, and it's simply a theoretical convenience. But it does mean the idea of the rigid definition of matter as being totally fixed in quantity is put at least into question. And the same goes for energy. When they added in all this extra dark matter in the late 20th century, it meant the universe should have much more mass than people had previously thought. And the universe is expanding, and the idea was that the matter of the universe should pull the universe together again. If there's enough matter, the universal expansion should come to an end. It should stop expanding and then begin to contract, and contract faster and faster until it underwent the opposite of the Big Bang, known in the trade as the Big Crunch, and the universe ended in tears. Everything just vanished into an ultimate black hole. And some people tried to draw a reassuring conclusion from that, saying, well, maybe that would just be the beginning of the next universe, the next Big Bang. That's called the bouncing universe model. And these were the ideas that were taken very seriously in the late 20th century. But then observations by astronomers showed that the most distant galaxies, showing that they were slowing down, but faster than they should have been. The expansion of the universe turned out to be accelerating rather than decelerating. So why was the whole universe expanding faster and faster? Well, no one had an answer for that, so they had to invent a cause for this expansion, and that cause was dark energy. A new kind of energy was invented to explain the expansion of the universe. And now it turns out that 95% of reality consists of dark matter and dark energy. It's as if physics has discovered the cosmic unconscious. No one has a clue what dark matter and dark energy are. And what's worse, most equations of dark energy suggest that the total amount of energy per unit volume of dark energy is the same. Since the universe is expanding, the volume of the universe is increasing, and therefore the total amount of dark energy should be increasing too. The universe is now a perpetual motion machine. The more it grows, the more energy it creates, and the further it grows. Well, that's the state of the art at the moment. And there are some astronomers and cosmologists and theoretical physicists who think that something's gone horribly wrong. If physics is saying the majority of reality is completely unobserved and has no reality except in the equations of physicists, are we leaving behind the realm of empirical science in favor of a kind of ideological system which is disconnected from physical objective observations? Well, that's one problem with the principles of conservation of matter and energy. Another is that some astronomers have suggested that matter itself is created as the universe expands. The great British astronomer Fred Hoyle suggested that as the universe expands, in the gaps in between, new matter is created in what he called the steady-state universe model. This was considered to be refuted by the Big Bang model when it became orthodox in 1966, but it's been resurrected in a new form as a C field, a creation field, or a quintessence field, which is supposed to give rise to new matter and energy within the universe. And the astronomer Halton Up postulated that quasars, which are extremely energetic objects seen in the universe by astronomers and are believed to be very far away from us, were actually centers in which galactic centers were creating new energy, and the quasars were new energy being spat out of galactic centers, so that there's a creation of energy and matter within the universe as it goes along. Well, those are dissident views because most astronomers regard them as heresies because they don't agree with the conventional dogma that matter can't be created or destroyed except at the moment of the Big Bang. And those areas of debate and dissent on the fringes of physics and cosmology.
Find out more on advire.life.